Global warming is the product of increasing carbon dioxide in the atmosphere, which has now reached over 410 parts per million. Its natural abundance should be on the order of 280 parts per million, so we're closing in on a doubling of carbon dioxide. CO2, along with a group of other gases, will trap heat that come off of Earth's surface once it's been warmed by the sun. And you can see the temperature rise nearly parallels the rise in carbon dioxide. So CO2 accumulation is accelerating. Warming is accelerating. We've currently warmed the planet about 1.2 degrees Celsius above the natural background temperature, which is a little more than 2 degrees Fahrenheit. We're on track to reach 1.5 degrees C, the United Nations target, within this decade, and to reach 2 degrees C before mid-century. During the first 80 years of the 20th century, warming set a new temperature record approximately every 13 and a half years. But since 1981, we've set a new annual temperature record every 3 years on average. And with only 1.2 degrees C of warming so far, researchers have already documented a 10% probability of sea level rise reaching 2 meters by the end of this century. Antarctic ice melt has tripled over the past 5 years. Greenland melting has quadrupled in the past decade. Greenland and Antarctica may have tipping points as early as 0.8 degrees C, which we passed in the late 20th century. And a tipping point means that either of these ice sheets might already be in a state of irreversible melting, which is likely to play out over centuries. Antarctic sea ice volume is down 50 to 70% since the first satellites in 1979. There's been a 12% increase in extreme rainfall around the world and a 10% increase in drought. Weather-related natural disasters have more than tripled since the 1960s, and this has significant insurance implications. Annually, these disasters cause more than 60,000 deaths. And 66% of humans currently face a water shortage for at least 1 month each year. There's been a 15% decrease in global vertical ocean circulation, which exports heat from the surface down to the deep ocean. And that decrease is leading to increased sea surface temperatures and air temperatures. And with warming beyond 2.5 degrees C, this decrease may reach 45%. The 5 great ocean gyres are shifting away from the equator towards the poles with massive ecosystem implications. The ocean is warming, it's acidifying, and it has lost 2% of its dissolved oxygen since 1950. There's been a 60% decline in the natural animal kingdom, consisting of mammals, birds, reptiles, amphibians, and fish since 1970. Over 500 species of land animals currently are on the brink of extinction, meaning that there are less than 1,000 individuals, and they're likely to be lost within the next 2 decades. We've seen a 46% decrease in the number of trees since the start of civilization, and we're currently cutting down 15 billion trees each year. This leads to the deforestation of 40 million acres annually, and nearly 1/3 of fish stocks in the oceans are overfished, and more than 50% have reached their sustainable limit. Hurricanes are changing in ways that are extremely dangerous for humans. And coral reefs are unlikely to last to mid-century. Because of these problems, the United Nations Framework Convention on Climate Change in 2015 established a goal of stopping global warming before 2 degrees C, and eventually all nations signed on to this, and to pursue efforts to end warming before it reached 1.5 degrees C. This is the history of CO2 emissions since the mid-18th century. And this is what needs to happen to CO2 emissions. We need to, as a global community, go to zero greenhouse gas emissions within 30 years. That would stop global warming at 1.5 degrees C. And it means annual decreases of 7.5% in greenhouse gas emissions this year of 2020 and every year hereafter. Emissions must end by 2050, and we have to remove CO2 from the air for the next several centuries. And if we want the developing world to build systems of food and water security, medical, educational, and transportation systems equivalent to the developed nations, then the developed nations really needs to reach zero emissions by 2030, allowing more time for the developing world to continue to use fossil fuels, because that is the embedded infrastructure that they have in place to achieve these social goals. Unfortunately, fossil fuel use is accelerating faster than renewable fuel use. And just last year in 2019, the use of fossil fuels, oil, coal, and gas, grew faster than the use of renewable energy or non-carbon energy. And CO2 emissions are projected by every global energy economist that makes these projections to far exceed the Paris Agreement. CO2 emissions are projected to continue past mid-century, where they should be decreasing towards mid-century. Greenhouse gas emissions grew 1.5% in 2017, 2.1% in 2018, 0.6% last year in 2019, and they're projected to fall anywhere between 3 to 6% this year. So because of the presence of the pandemic and the fact that it has, the quarantine of people around the world has brought the world economy to its knees, we may actually achieve the required cuts in greenhouse gas emissions in this year, 2020. But the expectation is that once there is a vaccine, or we have learned to assimilate our lifestyles and our economies to the presence of COVID-19, that greenhouse gas emissions will ramp up once again. And that puts us on a pathway to about 3.0 to 3.5 degrees Celsius warming before the end of the century. For every 1 degree C of additional warming from today, we see the expansion of intolerable heat and humidity conditions that will displace 1 billion people. And so we're looking at on the order of 2 degrees C additional warming this century, and thus the displacement of on the order of 2 billion people, most of whom are in the tropics or subtropics of continental areas. Where will these people go? How will host countries assimilate these people? Will they be welcoming? Or, as we have already seen in the case of Syrian refugees moving into the EU, will they ultimately be not welcoming and close their borders? A big part of the rise of infectious disease is because of habitat loss. This background photo shows the intrusion of a soy field into the Amazon rainforest. Since 1970, food crop production has increased 300% in order to feed the growing human population, and half of all agriculture expansion has come at the expense of forests. We've destroyed an area the size of Africa in order to grow animals for eating. We're deforesting the planet at the rate of 30 football fields per minute, largely to raise cattle and the grain to feed them. 43% of all ice and desert-free land, 2/3 of all freshwater use, is for food production. Over 80% of farmland is used for livestock, but it produces only 18% of food calories and 37% of protein. Cattle and the grain they eat use 1/3 of all available land surface on this planet and 16% of all available fresh water. 1/3 of worldwide grain production goes to feeding cattle. Producing beef generates 100 times more greenhouse gas than plant-based food, and monocrops of corn use synthetic pesticides and nutrients, leading to the pollution of adjacent watersheds. And 78% of coastal dead zones around the world are attributed to this sort of extractive agriculture practice. Deep plowing of fields opens soil to drying, erosion, and oxidation, and actually causes soil to release CO2 to the air where it was safely stored before extractive agriculture practices. This habitat loss brings animals and humans into contact, and diseases will jump into the human species in what are known as spillover events, and these diseases that have animal origins are known as zoonotic disease. In fact, 3 out of every 4 new or emerging infectious diseases come from animals. Zoonotic viruses can be carried by wild rodents, bats, primates, and deer, and we've seen 335 zoonotic diseases emerge in recent decades. They're often carried by ticks, mosquitoes, fleas, and snails. We can come in direct contact with them in wet markets where humans interact with animal body fluids. And these diseases can be food and waterborne. You're familiar with many of these zoonotic diseases: Ebola, HIV, dengue, malaria, West Nile virus, Zika, SARS, MERS, anthrax, the Marburg virus, and the latest is COVID-19. There is a strong climate change connection. There are expanded vector ranges for carrying and exposing humans to these diseases. Floods and fires and other types of extreme weather events caused by climate change drive animals and humans together. Drought and heat wave are among these. As an example, dengue fever has increased 30-fold over the past 50 years related to increased temperatures. And anthrax, bird flu, encephalitis, Zika, Ebola, dengue, hantavirus, malaria, and several others are occurring with greater frequency. And we see they will spring up in human populations following unusual extremes of temperature, rainfall, or drought. The second way that these zoonotic diseases spill over into human communities is through concentrated animal feeding grounds. These are a breeding ground for especially virulent pathogens. Factory farms generate 98% of the nation's meat in the United States. Normally, a virus will evolve a more moderate virulence to keep from killing their hosts. But in factory farms, animals are densely packed and host-to-host transmission is easy. There's less evolutionary pressure to reduce virulence because when a host dies, it's immediately replaced with another one by the farmer. There is a link between intensive poultry production and the emergence of highly pathogenic forms of avian flu, which have a 60% mortality. Europe and the US are the world's biggest exporters of swine flu or are the biggest exporters of swine or pork, and also its biggest exporters of swine flu. We keep pigs, chickens, and turkey and beef alive by pumping them with antibiotics. We get the additional benefit of seeing them grow faster. And very often, accompanying the antibiotics, we inject them with growth hormone. In fact, nearly 2/3 of drugs important to human medicine in the United States are sold for this purpose, for food animal use. Overuse of these medicines drives the rise and spread of bacterial resistance, which is a major concern, especially in hospitals. With the rise of human population from its current level of 7.8 billion, projected to reach 9 or 9.5 billion by mid-century, how will we double or triple food production without unleashing a host of new infectious diseases is a major problem. And climate change sets a backdrop which fights against our attempts to keep pandemics such as COVID-19 pandemic in check. There's a major social equity issue here as well, as the expansion of food production occurs in rural communities. Many of these foods are produced near or in aqueous environments, including rice, for instance. This does lead to increased health because of abundant food availability and improved nutrition, not only for these farming communities, but for those of us who live far away from the farming communities. However, it also leads to increased vectors of human pathogens, which do not typically impact consumers that are in urban areas, but they are expanding in communities that are producing the same food. So we see these farming communities experiencing a rise in various types of illnesses such as malaria and schistosomiasis. So I'll end here with a simple message that eating plant-based foods is the most powerful personal choice we can make to reduce our impact on the planet.